Looking at Roman numeral 6 here, the rules for significant figures when it comes to math calculations are pretty straightforward, but they tend to confuse students because they're different depending on the specific operation that you're doing. So the first thing we're going to write, and I'm going to use just different colors for this all together so that hopefully it stands out in your mind as something different, is that we will always round to the same number of decimal places as the value with the least number of digits after the decimal. So we abbreviate digits after decimal as DAD. When you are looking for digits after the decimal, it is exactly what it sounds like. You are counting how many places, how many digits are after a decimal. So, for example, down here in this box, if I have this operation of addition and more addition, this number has 1, 2, 3 digits after the decimal. So I would give that a 3. This 85.0 has 1 digit after the decimal, so I would give it a 1. And this 9.815 has 1, 2, 3 digits after the decimal. So because we are adding, we're in this adding and subtracting rule, we are looking at digits after decimal, not significant figures, and we will round to the same number of digits after the decimal as the number that we used in our calculation that has the least number of digits after the decimal. So in this example, this that has only 1 digit after the decimal has the least number of any of them that we're using in our calculations. You see how I got that? So because of that, when we round our answer, it's going to be rounded to 1 digit after the decimal. Completely different rule than the significant figures that we just learned about, so that's why I'm trying to make an emphasis on this rule is literally just counting the decimal places. So if you type this plus this plus this into your calculator would tell you this, and I need to round it to 1 digit after the decimal, which means that I'm rounding to that spot. When you round to 1 digit after the decimal, you need to be looking one place past that to see if this is going to round that digit up or if it's going to remain the same. So 3 is low enough, it's not going to round the 4 up. We never round down, so this means that our final answer, the correct answer to be written down, rounded appropriately, is going to be 102.4. I have 1 digit after the decimal. Let's try another one with that same rule. So this one, we are also adding, so we're using the same rule. It's going to be based on the digits after the decimal. So when I'm looking at this number, 230.72 has how many digits after the decimal? Can you tell by looking at it? 2. So it's not a trick question. It's as simple as it sounds. 2 digits after the decimal. So this one has 2. This number right here has how many digits after the decimal? 5. I have 1, 2, 3, 4, 5. We're rounding to the one with the least. So the one with the least number of digits after the decimal is 2. So my final answer needs to have 2 digits after the decimal. So if I plug all of that into my calculator spits out this answer. I need to round to 2 digits after the decimal, but that means I'm also looking at the next one. So I'm looking at the 3rd digit after the decimal. In this case, that 8 would round the 2 up. So when I record my final answer, it would be 230.73. Not 0.72, because that means that I'm not taking into account how it actually rounds. So the basic rounding rules of if it's a 4 or below, it doesn't affect the number. If it's 5 or above, you're going to round up to the next one. So the number of significant figures when you are adding and subtracting is just the digits after the decimal rule. Notice we didn't pay attention at all to the fact that these are leading zeros, they're technically not significant. That doesn't matter because in this example we were adding, so we're following the adding and subtracting rule. Make sense? Okay, the next part, we go back to our significant figures that we just learned. So in this one, I'm trying to find a different color, blue hopefully. Okay. In this one, for multiplication and division, your answer will contain the same number of significant figures, significant digits, as the number with the least number of sig figs, significant figures. I'm going to abbreviate that as SF. So you find the number that has the least number of significant figures, and your final answer should match that same number of significant figures. So I'm going to skip this example because it's subtraction. You'll go back and do that in just a second. But for this one, since we are multiplying, we're using the multiplication and division rule, which is based on not digits after decimal, but significant figures. So this is following the same thing that we were doing up here, where I look at each number and I say, okay, 6.77, this is 1, 2, 3 significant figures. 0.9, this is a significant figure, and that leading 0 is not going to be significant. So 0.9 has 1 significant figure. So since we are multiplying and dividing, I need to round to the least number of significant figures of a number that I used in my calculations. So in this case, that would mean 1 significant figure. If this is the answer that I calculate, it does not matter how many decimal places were used here. What matters is that I'm going to match 1 significant figure. So if I round this number to have 1 sig fig, that would just be the whole number 6 with no decimal places at all. Then if I do this last example here, 56.200 divided by 260.5. If I'm looking at these numbers and we are dividing, that means we're doing the least number of significant figures, so I need to count the actual significant figures in each number. The 5 is significant, the 6 is significant, and the 2 is significant. What about the zeros in this number? Yes, because they're trailing zeros and there is a decimal in the number. So since there's a decimal in the number, both of those are significant. So 1, 2, 3, 4, 5 significant figures for that number. And then this is significant, this is significant, that is significant. So what rule does this 0 fall under? Trap 0, it's significant also. So this number has how many sig figs? 4. Based on the numbers that I'm using in my calculation, what is the least number of significant figures? 4. So my final answer needs to have 4 significant figures. So if I plug this into my calculator, this is the answer that it calculates. I know, looking at this, that my leading 0 is never significant. I'm going to include that in my number because that's something that makes it easy to read. So I'm still going to put the 0 even though it's not significant. And then I need 1, 2, 3, 4 significant figures. So my answer is 0.2157. The 3 doesn't change the value of it at all. We don't round it up. And then just to double check yourself at the end, that's 1, 2, 3, 4 significant figures. My leading 0 is still not significant. Good? All right, practice by doing this middle one on your own, and then we'll go over the answer in just a minute.